Now, let's continue applying powers, and the first thing we're going to do is evaluate a discriminant. At the end of the semester, we're going to be solving quadratic equations using the quadratic formula. This is the quadratic formula. Part of the quadratic formula is this expression. It's known as the discriminant. To evaluate a discriminant, we're going to be told values for b and a and c. We substitute them and then simplify. For instance, if I'm trying to find the value of the discriminant when a is -1, b is -4, and c is 6, I'll start with my discriminant. I'll replace b with -4, a with -1, and c with 6. Then I'll follow the order of operations. Power will be first. Next, I'll multiply left to right. 4 times -1 will be -4. -4 times +6 will be -24. And then I'm subtracting a negative value, which I like to think of as adding a positive value, and that gives me 40. So the value of my discriminant is 40. Try this one. After replacing values for b and a and c, we'd begin by finding the second power of 8, which is 64. Then multiplying left to right. 4 times -4 will be -16. -16 times -4 will be +64. And the difference will be 0. Here's another. After replacing my values for the letters, I'll begin by finding the second power of -7, which is 49. Then 4 times 3 is 12. 12 times -2 is -24. 49 minus a -24 is the same as 49 plus 24, which is 73. And here's one more. First, I'd replace b and a and c with the values I've been given. The second power of 1 is again 1. Then multiplying left to right, 4 times -1 is -4. -4 times -4 is 16. And 1 minus 16 is -15. Now, let's practice applying a quadratic function. A quadratic function has a form like this, where we have a second-degree term. Or like this. Again, the point being we have a second-degree term. So notice part of this is a linear function. This is the form mx plus b, where m is 4.5 and b is 16.8. And the same here. M is 88 and b is 0. But then this second-degree term is now included, and that's what makes it a quadratic function. And to evaluate a quadratic function, we just replace the variables on the right with the value we've been given, and we simplify. See if you can find the value of c if t is 0. Substituting 0 for t on the right side, and following the order of operations, we get that c is 168. What about if t is 5? Substituting 5 and following the order of operations, I find the value of c is 255.5. And how about if t is -2? What do you get? Evaluating -2 gives me a c value of 161. Now let's put these skills to practice by answering some questions about, in this case, chickenpox. This function is giving the number of cases of chickenpox if we supply the number of years it's been after 1982. Notice that each case of chickenpox is actually 1,000 cases. Find the number of cases in 1982, which would be year 0. Substituting 0 for the time and simplifying shows that in 1982 there were 168,800 cases of chickenpox. Remember, we have to multiply our final value by 1,000. Find the number of cases in 1994. Since 1994 is 12 years after 1982, I'd substitute 12 for t and simplify and find that by 1994 there were approximately 129,200 cases of chickenpox in the United States. Here's a function that gives a good approximation for the cost of 1 year of tuition and fees for a 4-year public college in the United States. Notice that x is the number of years after 1970. Can you find the cost of college in 1970? Since 1970 is year 0, we would substitute 0 for x and find that a year of tuition and fees for a United States public 4-year college in 1970 was a total of $692. What would the cost be in 2015? Since 2015 is 45 years after 1970, I'd substitute 45 and find the estimated cost in 2015 was around $9,742. Well, that concludes this video where we continued to apply powers.